Relations and functions. This is a unit. It's a pretty quick unit. I would say it's fairly easy, but it's more about definitions and understanding what we're talking about. Now it's abstract because it's definitions, but the idea is just to understand what a relation and a function is, and what domain and range is to begin with. Those are the two main things in the unit, and then there's some stuff at the end that we'll do in another video. And this would be used in the very first unit you see in grade 11, either in the applied or the pre-calc. So let's figure out what these things are. We'll see how we use them in grade 10 right away. So relation. What is a relation? Well, a relation is just a word we use to basically describe anything that can be put on a graph. So it might be a graph itself. It might be a statement, like when I say 2 times a number, or 3 more than 5 times a number. It might be an ordered pair, just an XY ordered pair of 5, -7, something like that. So those are things that could be considered relations. Excuse me. And then a function is a special type of relation. And this is the one that we use basically through high school. Now we see just relations as well, but we generally kind of try to stick with just functions. You'll hear me talk about rational functions, polynomial functions, trig functions, all these things as we go through the rest of high school. And all a function is a special relation where when you graph it, an x value is distinct. It only has one y value. So for instance, I'll just quickly do one here. If I had 2 ordered pairs, and there was 3, 5, and then you had another ordered pair on that same graph that was like 3, 7, that would not be a function, because this x value of 3 has more than one y value. Okay, that's how simple the definition of a function is. So an x value, whatever it is, can only have one y value. Okay, I know there's got to be more to it, but there really isn't. And I mean, we don't even think about the definition of a function as we go through this. It's just we just see it. Okay. So now, vertical line test. This is something we use on graphs, and I like to use this on equations too, because once we have something graphed, then we can tell just by using a vertical line test. So if you drew a vertical line on a graph and it passes through more than one point, then that relation is not a function. So let's look at our 3, 5 and our 3, 7 thing here. Well, you can imagine 1, 2, 3, and then I got 5 here and 7 here. If I plotted these 2 points, if I drew a vertical line on this graph, you can see how many points I go through. I go through more than one point when I draw that vertical line. So that tells me it's not a function. So we already knew from the definition of a function that this x value of 3 had more than one y value. But if we didn't have those points and we just had 2 points on a graph, we could draw a vertical line. All right, so now let's keep going here. The domain of a function or domain of a relation is just the x values that make up a relation. So this could be just specific x values, like in our situation here, the domain is 3. It might be a whole statement, because you think about a line, for instance, there's infinite number of points. So how do you state that? So we'll look at that. And then range is just the opposite, so the y values. So again, if I was to choose one of these two, I would say the domain is kind of the more important one, or the more common one to talk about. But your range is equally important. And again, here on this specific example, our range would just be 5, 7. But again, if we had a line, it might be a statement, like an infinite number of points, and how do we write that? So we'll take a look at all these things. So here's some examples. So I've got looks like 6 examples written out. So determine whether each relation is a function or not. There's our first part of the question, and then we'll state the domain and range of each as well. Okay, so we have to remember the definition of a function, either just the straight up definition or using the vertical line test, and then we can state the domain and range, domain being the x values. And I always remember that as the king's domain, right? He's looking over the horizon, the x-axis of his domain, and then the range is our y values. So for question A here, I'm going to look at the x value. So I'm looking at x is 2. Do I have any other x's that are 2? No. Okay, so that's good. X is 4. Good. X is 1. So I only have individual x's. I don't have multiple x's of the same value. So this one is definitely a function. So I'll just put function. We know that it's a function, not just a relation. And its domain, the domain, I guess I can write the domain like this, is, here, I'll do that a little bit neater. Our domain is, we can write as 2, 4, and 1. And the range of that guy would be 3, 8, 9. So there's our answer to A right there. So it's a function. The domain is just your x values. Normally I would write my x values in numerical order, like you could say 1, 2, 4. And then your range is your y values, which is just 3, 8, and 9. Okay? So that's our answer to A. Okay, so let's look at our answer to B. Our answer to B. So I'm going to look at my x value. So I got -3. I don't have another x value that's -3, so that's distinct. I'm going to look at my x value of 6. Oh, I've got another x value that's 6. So x is 6 has how many y values? I see a y value of 2 and a different y value of 1. And the definition of a function says that an x value can only have one y value. Well, this x value of 6 has 2 y values. He is definitely going to be in trouble here. So it is not fun, right? It's not a function. And our domain looks like it's -3, 6, right? Our range, whoops. And you'll see as we get on and we learn how to write domains and ranges, that we'll get more detailed about it, okay? And I'll even show you in this example, in this question, how to write this a bit better. Our range is 1, 2, 3. There's our range. So there's our answer to B. Now I'll show you how to do this C, and we'll maybe do the brackets again, but just whether it's a function or not, we can see that it's distinct x values. There's a little bit of a pattern here, so I'm going to show you how to write this a bit better. So we can tell that it's a function because no x value shares a y value. You can see x is 1, there's only one of them, and the pattern would be, the previous point would be 0, 1, and so on, and so on, and so forth. So now, here's how you should be writing your domains. So you need these fancy brackets. And if you look here, this is the bracket that I'm actually trying to draw. So for this domain on C, I would go ... because it's a pattern. 1, 2, 3 to show the pattern, ... Fancy bracket. And like I'm doing there, I should have maybe had these fancy brackets here, but I'm not very good at drawing them, so I just squiggle them in there. They kind of look like 3s sometimes. They look like straight lines sometimes. I just try my best. Here we go. Range. Fancy bracket, ... 2, 3, 4, ... Fancy bracket. Again. So now, there's the answer to C. So again, I hope that clears you up for for just those questions that are distinct points. That's kind of the beginning, right? Just deciphering whether it's a function or not based on the definition. Now, as we go on, we'll start to see some other ways. So I'm going to erase a bunch of this. You guys can put it on pause and finish up the notes or whatever, okay? But I'm going to clear this up so I can show you how to do the rest of this stuff. And hopefully you'll see kind of where we're going as we get closer and closer to grade 11. So, like a linear relation, y equals 2x plus 4, what I would always say is to graph this. Any equation. And if I don't know how to graph it, I would use a table of values and I would try to graph it as close as possible. But we know how to graph linear equations, so I'm going to quickly just throw this on here. This is like assignment H from our analytical geometry unit. So I go up, my y-intercept is 4, 1, 2, 3, 4. And I plot that on there. And then my slope is 2, so positive 2. So I'm going to go down 2 and left 1. And left 1 so that we can see it on the graph still. So that line keeps going on like that forever and ever and ever. Now, because I have a graph, I can use a vertical line test. So when I draw this, you can see that vertical line goes through 1 point. And by definition of the vertical line test, this is a function then, because if the vertical line test passed through 2 points, or 3 or 4, so basically anything more than 1, then it's not a function. So I'm going to write this is a function right there. Now the domain is a little different story, and our range. This is where things change, because let me get rid of that. Whoops. Let me get rid, maybe I won't. Maybe I'll just go like this. You can see that there's infinite points. I'm trying to draw these on with a yellow that make up this red line. So how can we just say specific points when there's infinite points that go on forever and ever and ever? Well, this is where statements start to come into play. I like to call this mathanese sometimes because it's like a different language. We're writing in a different language. So for our domain, some people say, okay, well, what x values make up this red line? Well, you can see that our red line keeps going left forever, and it keeps going right forever, and everywhere in between. So we would say from negative infinity all the way to positive infinity. I like to say, well, any number, so all my x values that are a part of the real number system. Remember those fancy brackets? So a lot of kids get used to saying XER. Well, X is an element of the real number system, and you learned about all your number systems. You think about the whole number system, the natural number system, integer number system, and if you didn't, well, something was missed, and we'll have to review that at a different time. But you can just say if X is a real number, if you can think of a number, it's on your graph. I don't care what number it is. It's going to be on your graph. Now, you say, well, aren't all numbers real? Well, no, there's imaginary numbers too, and that's a whole nother level when you get into like grade 12 and calculus and beyond. Okay, so basically, if you can think of a real number, -5, 2.4, 2.73, 5.98721, those x values will be on this graph. They'll have a distinct y value. So now you think about the range now. Well, range is the same idea. It keeps going down forever, and it keeps going up forever. So we can say y is an element of the real number system again. So that's a special one. Okay, and you have to think about that. So that's the only time when you think of a graph going on forever and ever and ever, all directions, that's when you use that x as an element of the real numbers system. So you'll see in the next example, it's not like that. And then in example F, you'll see that part of it is like that, but part of it isn't. Okay? So I'm going to erase this again so that we can work on our next examples with room. Okay? So again, if you're given an equation, graph it. But I can tell you this, if it's a linear function, y equals mx plus b, you know that it's a function, you know that the domain is going to be x element of the reals, and you know that the range is going to be y is x element of the reals. So there's no real thinking about. Now, for this one here, this circle graph, well, watch the vertical line test. How many points did I just go through on that blue circle? Well, I can see 1, 2. So there we go. It's not a function. Not fun. Okay? Not a function. So, I'm going to erase that now. I still got to do domain and range just because we're going to learn how to do this. So, watch this closely. There's two types or two ways we can answer this stuff. Now, I always deal with set notation in grade 10 because I think it's maybe the harder one to learn, so I like to use it earlier so that you have more time with it. And then set notation is the second one, or interval notation. Okay, that'll come in grade 12. We see more often. Okay, so here we go. I got to think of the domain, and it is my x values. Now this is not an easy concept to understand, so make sure you're with me on this. Let's see here. I'm going to move this up here for you guys and make it bigger. Okay, bear with me here. So there's our circle. All right. Now, look at our x value would be on our circle. I can see from -5 all the way to +5 are x values on our circle, right? Like if I said -4, could you find a point on the circle? Yep. If I said -1.5, yep, I could see that. 0.5, yeah. So how would you describe that to somebody reading your work? I would say it's anything between -5 and 5. That's how I would describe my domain. So any x value between -5 and 5. So here's how this is written. And remember, this is hard. This isn't easy. And of course, we're going to see this again next year. So you don't have to panic too much. And this is probably the higher level stuff. But I would write this as -5 is less than or equal to my x values, right? -5 is less than all my x values, right? And all those x values are less than or equal to 5. Fancy bracket. Okay? So, again, let me walk through that one. -5 is less than all these x values, and all these x values are less than 5. And that is how you do what I call a betweener. Okay? Because my x values are between the two outer limits. Okay? So now, let's go look at range. Range works almost the same on this one. And this is just one specific type of statement. So you've either got that x element of the reals, or you got a betweener, or you're going to have what I call a splitter here right away. So now range, though, you can see that our range is also between some numbers. Looks like -9. -9 is less than all my y values, and all those y values are less than 1. So less than y, and all those y values are less than 1. So when you've got some boundary, some region where your x's and your y's are held in, then you have to write it as a betweener. Okay? So now I'm going to close that up. That's not real easy to see, especially being shown it through this method here. This isn't the greatest thing in the world, but that's your first introduction to writing a betweener, splitter, or domain and range, that's not great. So now let's look at this F. This is more what you'll see in grade 11. Well, vertical line, I pass through 1 point. No matter where I draw a vertical line, I'm only going to pass through 1 point. So, yep, that's a function. Great. Now, domain and range. Now I'm gonna draw this a bit bigger. I'm gonna do the same thing I did on the last question. I'm gonna make this a bit bigger so we can look at it. Okay. So let's even go bigger. There we go. And I'm gonna put arrows on these. Let's assume this goes forever, which it would. Okay. Now the domain. I look at this and see that these arrows are going to keep going left and keep going right. All the way down forever and ever and ever, right? So if I go all the way left and all the way right, everything in between is there. That goes back to that first one, and we could say, okay, fancy bracket. X is an element. That's just like a rounded E of the real number system. Capital R, fancy bracket. Okay, and the reason that is because every X value you can think of, any number, is going to be on there. Now, for the range, okay, think about the range. What is a range? Range is the Y values. Again, this is not an easy concept. It's abstract. It's your first time really facing this. So my Y values, I notice up here that what's the highest it goes, right? What is the highest? Well, the highest is a 1. So if I was to describe this graph to somebody, I would say, well, all my Y values are what? Less than 1? Okay, so then let's say that. All my Y values are less than or equal to 1. And that is a kind I describe as a splitter. Okay, so you've got your betweeners that are written like this. They're never any different than that. They're always less than symbols, stuff like that. This graph here, I would write as Y is less than 1. Now, if the graph was going up from 1, you could say Y is greater than or equal to 1. Okay? I hope you understand that. Like if this red graph that's going down was flipped the other way, going up, your range would be Y is greater than or equal to 1. So there's no rules on what direction that goes. It depends on the graph. But for your betweeners, they always look the same. So if you end up with those on your assignment, and you will, you'll see those. Okay? So you've got a function on this one. Domain is exponent of the rails. Y is less than 1. All right. So I know it's abstract. I'm going to shrink this back down here just to squeeze it back in, so you guys can see that they're related, where these questions come from. Okay. I know that doing this abstract stuff's a little bit tougher this way. Try your best. Ask lots of questions. Hopefully I can help you out as it goes. And if one or two or three you want to get together and I can do some examples on here live through Meet or whatever, just let me know. Get a bunch of you together and I'll do a whole bunch of them. I'll find a bunch of different ones and we'll do it. Okay, good luck.